On this 2019 to 2025 Silverado 1500 with the 5.3 gas engine, P0072 may mean the ECM is seeing an ambient air temperature sensor signal that appears out of range for outside air temperature. The driver may notice an incorrect outside temperature display. HVAC or AC operation can be affected, and the module may fall back to substitute temperature values. The broad areas to keep in mind are the ambient air temperature sensor, its signal circuit, its low reference circuit, connector condition, and the ECM side of the circuit. For this code, keep the related ambient temperature faults as context, but diagnose the active target fault without getting distracted by a code list. The monitor runs with ignition on and the vehicle in service mode. For P0072, the setting condition is an ambient air temperature sensor signal greater than 88 degrees Celsius, 190 degrees Fahrenheit. The ECM input circuit has internal resistance connected to 5 volts, so the diagnostic logic is built around proving whether the sensor circuit, the low reference, or the control module side is driving the scan data wrong. Before the pinpoint checks, start with the basic system checks and follow a structured diagnostic approach. Then turn ignition on with the vehicle in service mode. First, see whether P0072 or another ambient temperature circuit fault is currently set. If it is set, move into circuit testing. If that group is not set, check for any other ECM or temperature-related codes. If other codes are present, check what they mean first. If no other codes are set, let the vehicle cool completely to ambient temperature. Then compare scan data to the real outside temperature. The intake air temperature sensor parameter should be within 15 degrees Celsius, 27 Fahrenheit, of actual ambient temperature. If it is not within 15 degrees Celsius, 27 Fahrenheit, go diagnose the intake air temperature sensor side. If it is within 15 degrees Celsius, 27 Fahrenheit, check the ECM ambient air temperature parameter. That should also be within 15 degrees Celsius, 27 Fahrenheit, of actual ambient temperature. If it is not, continue into circuit testing. If it is, the check is okay at that time. One caution here: the displayed temperature is filtered and updates periodically while driving. It rarely changes much while parked, and when available, the ECM ambient air temperature calculation reset can help the display update faster. For the circuit test, turn the ignition and vehicle systems off. Then disconnect the B9 ambient air temperature sensor connector. Before you trust a ground or low reference continuity check, remember that it may take up to 2 minutes for all vehicle systems to power down. Test between low reference terminal B or terminal 2 and ground. You want less than 10 ohms. If it is 10 ohms or greater, disconnect the K20 engine control module connector and check that low reference circuit from the component harness to the other end of the circuit. That continuity should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. If the low reference to ground check is less than 10 ohms, turn ignition on with the vehicle in service mode and look at the scan tool ambient air temperature. With the sensor disconnected, it should read less than -34 degrees Celsius, -30 degrees Fahrenheit. If it reads -34 degrees Celsius, -30 degrees Fahrenheit or warmer, turn the ignition and vehicle off. Disconnect the K20 engine control module and test the signal circuit terminal A or terminal 1 at the component harness to ground. That test should show infinite resistance. If it shows less than infinite resistance, repair the short to ground on the signal circuit. If it shows infinite resistance, the path calls for replacing the K20 engine control module. If the disconnected scan tool value is -35 degrees Celsius, -31 degrees Fahrenheit or colder, simulate the sensor by installing a 3 amp fused jumper wire between signal terminal A or terminal 1 and low reference terminal B or terminal 2. Now the scan tool ambient air temperature should go greater than 143 degrees Celsius, 290 Fahrenheit. If it stays 143 degrees Celsius, 290 degrees Fahrenheit or colder, turn the ignition and vehicle off, remove the jumper, disconnect the K20 engine control module, then turn ignition back on in service mode. Test the signal circuit at the component harness to ground for less than 1 V. If it is 1 V or greater, repair the short to voltage on the signal circuit. If it is less than 1 V, turn the ignition and vehicle off, and test signal circuit continuity from the component harness to the other end of the circuit. That should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the signal circuit. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. If the jumped scan tool value reaches 144 degrees Celsius, 291 degrees Fahrenheit, or warmer, apply dielectric grease to the connector terminals, reconnect the B9 ambient air temperature sensor, reproduce the operating conditions, and verify whether the DTC or symptom is corrected. If it is not corrected, the path moves to testing or replacing the B9 ambient air temperature sensor. If it is corrected, that branch is okay. For the static sensor test, place the B9 ambient air temperature sensor in a stable, temperature-controlled area for at least 10 minutes. Then measure resistance between sensor signal terminal A, or terminal 1, and low reference terminal B, or terminal 2. Compare the reading to the specified ambient air temperature sensor resistance data. If the reading is not in the specified range, replace the B9 ambient air temperature sensor. If it is in the specified range, that test is okay. After the repair, verify the repair and confirm the code stays gone. The clearing condition is that the condition that set the DTC no longer exists, so do not stop at clearing codes only. Recheck operation under the proper conditions and make sure the symptom does not return. Takeaway: use scan data first, then prove the low reference, the signal circuit, and the sensor response before replacing anything. For more diagnostic training, visit stepdiagnostics.com.